Okay. So part 2 of Parabolas. Now this was the problem we did yesterday. And I won't redo it, but again, you've got to do the focus, the directrix, axis of symmetry, and then do a nice graph. And the whole process hopefully is taking about 2 minutes. Okay, so interesting facts about parabolas. I kind of shared this the other day, and we talked about what your eyeball is. Light rays from the focus will bounce off parabolic. It's like a parabolic mirror, if it is a mirror. They will bounce off in parallel rays. That's why your headlights are often shaped in this parabolic shape. So, interesting engineering idea. Okay, so what if we had a graph here? Could you come up with the equation? Okay, so, well, the nice thing is, what do we need to know to come up with the, whoa, hold up. What do we need to know to come up with the equation? Well, first of all, it opens up upwards. So I already know, is it this one? Let's see, is it x squared equal to 4py? Or is it this one? Y squared equal to 4px. Which one is it? You should be able to determine this quickly, right? It's this one, right? Well, the only thing we need to do to get the equation is figure out what p is. P is the focal length. Well, you know what? What's interesting is that they didn't draw the focus on here. I have a feeling it would be sitting right there, though. I have a feeling the focus point would be right there. Someone tell me, why do I think it's right there?
Because the directrix.
Because the directrix is what?
It's opposite.
It's opposite, and that's 3 units, right?
Yeah.
And so that's a positive 3 units, right? If I go, oh, hold up. It would be right there. All right, so the distance to the directrix and the distance to the focus is exactly the same, and they're opposite. So that means the focal length, this is your P right here, right? So now you put this 3 in right here, okay? So you get x squared is equal to 4 times 3 times y. So you get 12 y is equal to x squared. Now how hard was that? That's it. I'll bet you guys can do this one in about 5 seconds maybe. Alright, 10 seconds. You got to come up with the equation of the parabola. 9, 8, 7, 6, 5, 4, 3, 2, 1. Someone please tell me they know what it is. Alright, so first of all, let's decide. Which way is it going? It's going left and right. So is it this one? Is it x squared equal to 4py? Or is it x squared equal to 4px? Y. Well, that's what I just wrote. What a retard. Hang on. I'm not retarded. You guys don't say that. That's a terrible thing. Stupid is what I should maybe say. Stupid. What a big stupid. Yeah. Stupid is like this, yeah. So maybe what I should do is write down, what should I do?
Y squared.
I should write y squared. So which one is it? 4px here. Yeah, this is the one I know. Like y is equal to x squared. I know that one is this one that we've always done a long time ago. That was our parent function in chapter 1. So that would be the one that opens up and down. So this is it's not this one, right? It's this one. And well, all I need to do is know my focal length. Well, this time I have the focus. -3, isn't it?
Yeah.
So that means y squared is equal to -12x. That's it. I mean, I hope that doesn't take more than 10 seconds. Really. Any questions? Alright, now let me talk to you about this problem. As we go through the chapter, I need everybody paying attention. As we go through the chapter, we're going to see an application problem, kind of like this one. And you'll have one like this for ellipses. You'll have another one like this for hyperbolas. And this is the type of application problem you should be prepared for on your test. They're all very, very similar. So let me show you how this problem works. And usually you got to think a little bit, but it's not that hard. So let's read it and see if we can figure out what to do, okay? The Euro dish, okay, developed to provide electricity in remote areas, uses parabolic reflector to concentrate the sunlight onto a high-efficient engine located at the reflector's focus. All right? The sunlight heats the helium to 650 degrees. That's hot. To power the engine. Write an equation for the Euro's disk cross-section with its vertex at 0, 0. How deep is the dish? Okay? So, first of all, they're not asking you, it's not 4.5. They're just asking how deep is the dish at that point. If you go straight across here, what is that depth right there? No, it can't be 5 because it's 4.5 from here to here. Oh, 0.5. Just subtract the 4. That might be right. You know, I don't know, but there is a way to do this. The first thing you want to do is get the equation. You've got to get the equation. So I'm going to give you the little hint. So here's how these problems work. Number one, get the equation first. Okay, you got that? Second thing, you need to plug in a point. Plug in a point. Okay, now usually this step here is the one that's a little bit tricky, okay? So pay attention so you see how this works. Alright, so this thing opens upwards, right? Yeah? You guys say yes now, right? So what does the equation look like? It's got to look like, let's see, x squared is equal to 4px, right? And can I find out what this p is?
Yeah.
Someone please help me out. Where is it?
8.5. Sorry, negative 8.5.
No, the 8.5 is the width of the dish at this point.
4.5.
That's the 4.5. You see, that's from this spot here, the bottom, up to the focus point is 4.5. So there's the 4.5, which gives us the equation. Because all we need to do is take 4 and multiply it by 4.5 and then x. And then we get, oh, excuse me, this should be y. I almost made a mistake. So our equation then becomes 18? What are you guys laughing at? Alright, so I have x squared is equal to 18y. Okay, so now here's where you got to think, because now we did that step there. You see, we do have the equation now, and that's always going to be the first step. Get the equation. I think I'll half credit on this problem already now. the tricky part is figuring out what point do you use. Well, here's where you're going to have to think a little bit. In order to plug in a point, you're going to plug in like an XY coordinate. Now here's the deal. One of these coordinates you're going to know, and one of them you're not going to know. So, because we're trying to find out the height up to right about here, that is actually the coordinate we do not know. So it's the height or the depth. That's the one we do not know. And what it means then is that we have to know this one. Is there anything, any x coordinate that's at that height? And here's where you look this way. You say, hey, there's an x coordinate right there. You see, if this are my x-axis, you come over this way, and then you go up that way, right? Well, likewise, you come over this way, and you can go up this way. You see? But it's this x distance that I do know, and it's that y distance there that I'm trying to find the height of. That's the height of the dish at that point. Does that sort of make sense? And it's like, well, I can show you. I have a cool, almost have the exact setup right here. And this is my toy. Where'd it go? What? Where'd my mirror thing go? Oh, here it is. Bam. Here.
Oh, that.
This thing. You guys have seen my frog toy, right? It projects the frog right here. Now, in just a few moments, you're going to understand why this works. Alright, so, but here's the thing. We're trying to find out the height right there. So if you measure from here to here, right there. Okay? Well, so I'm showing you now what that sort of looks like with a realistic type toy. So we need the coordinates. The problem is we need the coordinates right there. So what do we be knowing? The y coordinate is what we don't know. But I'm going to tell you that we know the x coordinate.
0.
It's not 0.
18.
0 would have been here. So the question is, what is the distance from here to here? There's a little hint up there. Here's a hint right here.
8.5.
No, now think about that. 8.5 is the entire distance across, right? I just want to go halfway now.
4.25.
Yes, there you go. This distance is 4.25. Do you see now? This is where you have to be clever to find out the coordinates of a point. And this step here is the hard step in this problem. Once you see this aha moment, you go, oh, okay, now I know the x-coordinate. The x-coordinate is 4.25. Now you know this needs to go in right there. Does that make sense? And then you can solve for y. Okay, so thank you for Joel for helping me. This is 4.25, and we square that. And then we say that's equal to 18 times y. I have a handy calculator here. 4.25. We're going to square that. And this side I get 18 point. And what I would recommend is don't round off on your calculator. And so I have 18.0625 is equal to 18 y. And now what I need to do is divide by 18 here and divide this side by 18. So I divide by 18 now, and I get 1.003. And by the way, what units do I have? This is in terms of meters, right? So it's about 1 meter deep at that point. Now why do you need to know that? Well, imagine if you're building the framework to build this. Okay, so what you would do, I'll try to show you with my toy here. This lays out flat first, right? You know it's going to be circular, So what you do is you cut out like a circular sheet of metal, and then how far do you bend it up on the edge here? That edge, you go exactly 1 meter up, and you go, that edge over there goes exactly 1 meter. The whole edge goes up exactly 1 meter. You've already done the calculation. So now it's a nice smooth 1 meter, nice curve. And then what you do is you pour the liquid that turns into a mirror type glass. Like if you've ever made a mirror, it's just a chemical. You start off with a regular glass, and you just pour this chemical in there. In chemistry class in Kennewick High School, they used to do this. And you can make mirror on almost any surface you want. You just pour it in there, and then that chemical, it's like a liquid at first, and then it's like it hardens. And then you have basically a mirror on any surface of glass. It's pretty cool. Anyhow, can you see where the hard part is? Okay, so let's review the steps again. You got to get the equation first. That's usually the easy part because all you need is the focal length. And that's what we got right there. But then you have to cleverly find a point. And it's usually out on the side somewhere. And you're going to know one of the pieces of information, but you're not going to know the other one. And usually the one that you don't know is what you're trying to find out. So in this case, it was the height or the depth of the dish. Now, let me just go to a quick page here. I want to talk about my frog thingy. You guys have all seen it, right? There's a dish here that's shaped like that, and then there's a dish that goes on top like that. You place the little froggy thingy in here, and you see there's a little hole at the top here, right about there. And what happens is that the frog is projected up to here. So it looks like there's a frog sitting up here. Now why is that? Okay, well, you have to think in terms of focus points. And see, so if you were looking at this parabola, where would the focus point be? And it's kind of right there. You see? So light comes in and it comes in this way, it comes in this way, it comes in whatever. But once it bounces off, it's going to bounce and go right through that focus point. Does that make sense? And so when you have your frog sitting in here, the light is reflected and stuff like this off this mirror, and eventually it makes its way up to here. And it's a little bit more detailed than that, but it projects the object right there. And so it's kind of cool. I'll leave this out on my desk. You can look at my froggy. As long as it's right smack, I want to set it right smack at the vertex, right? And if I set that there, and you can look at it, the frog looks like it's up here at just the right angle. And it looks pretty real. You can pass it around if you want. Look at it.
Get it, Jackie.
Now try not to move the frog. The frog needs to be at the vertex, the very bottom, in order to see it quite right. Do you see it? And you can move it so it's almost exactly sitting there. It's really cool. Okay, so I think that's pretty close to the end of our lesson. So let me see here if there's any more. That's it. So I'll stop the lesson now. And what you can have the remainder half hour to work on the assignment.